Well, we're chugging hard down the finish line here, and we're wrapping up our trig equation chapter. And I just wanted to kind of have a finale that kind of combined all the different techniques we've seen within this chapter. And let me introduce you to all the techniques. First of all, we started with a very basic trig equation, one that we call a first degree that never has an exponent higher than 1. And then we graduated to what we call second degree trig equations, where we're starting to see exponents of 2. We started off with some friendly rascals, ones that were factorable either with the technique of GCF, or maybe a difference of 2 perfect squares, or maybe they were factorable because of a trial and error method that we could apply to a trinomial. And then things started to get a little feistier. We found some second degree trig equations that weren't factorable, and so we started employing the quadratic formula. And then we saw some ones where we had to use substitution, and there was 2 main types of substitution. One was with the Pythagorean identities, also known as the Godfathers, or we could make a substitution based on a double angle formula. So those are the 6 techniques that we really spent basically a day on each one of those. Over here on the right-hand column, I've brought in 6 different equations here, and I want you to try to match them up with the appropriate technique. So go ahead and hit the pause button, and I want you to basically play a matching game. Take each of these equations. You can start writing them in your notebook perhaps, and leave a big chunk of space between each one. But I want you to basically match up the technique in blue with the equation in red and see how you do. Okay, after taking a few moments on your own time here, here's how I matched them up. I thought I'll get the easy ones out of the way, then I'll kind of funnel my way towards the harder ones. I thought the basic one was fairly simple because this was the only equation here, number 3, where there wasn't any squared signs, I guess. Well, with the exception of 5 being the double angle. So I might as well go to that one. Let's do the substitution goes with number 5 because of the double angle right there. The other substitution was the one on top with the Pythagorean identity. What gave it away was I had a sine function here, but then a cosine function here. So I knew that I needed to rewrite the equation strictly in terms of one trig function. So I used a Pythagorean identity for this term right here. Let's see, the next one, I thought the factorable Gcf was pretty straightforward. I only have a binomial here with 2 terms. They both have a 2 sine of x in common, so I could factor that out. I thought the last 2 were the more difficult ones that you maybe had to write down and kind of play with a little bit. The one that I ended up getting to be factorable was number 4 with the cosines in it. A little bit of trial and error. It worked out really nice. And then the one on the bottom here, if you can follow the chaos of my arrows, this is the one that I'm going to use the quadratic formula on. So for the rest of the slides tonight, I'm going to go ahead and I'm going to solve these 6. And hopefully when the video ends tonight, we have developed enough confidence that we can really dominate and fly through these trig equations. Alright, I'm going to do them in the order, not necessarily the order they were in on the previous screen. I'm going to do them in the order that we would have seen them throughout this chapter. In the first day, we just started with basic trig equations, the biggest exponents of 1, also called a first degree. And our domain up here in the bright blue is from 0 to 360, so we are in degree mode. We're going to express our solutions in degrees, not radians. First thing I want to do is I want to try to get all my signs on one side. So I'm going to subtract the sign that's on the right side over to the left side. And what that's going to do is that it's going to give me 2 sine of x. Meanwhile, I'm going to grab this 4 radical 3 and subtract him over. And as I combine those like terms, that's actually going to give me negative 1 radical 3. And then I'll simply divide the 2 over. Now, a couple of things here. We recognize that the value, radical 3 over 2, is negative. So my final solutions are going to be in quadrants 3 and 4 because according to all students tip cows, signs negative in the 3rd and the 4th. So anyway, my reference angle, according to my flashcard, says that the angle must be 60 degrees. So 3rd quadrant, we're going to do 180 plus that reference angle to get a solution of 240. That's 1. And then the 4th quadrant, we're going to do 360 minus 60 to get a solution of 300 degrees. So those are my 2 solutions, 240 and 360. Certainly, as we deepen our understanding here, you're going to be able to whip through these really fast. The next one I chose was the one that was factorable according to the GCF. There's only 2 terms. Anytime you see a binomial, you probably should start entertaining the idea of a GCF or dots instantly. So I'm going to factor out a 2 sine of x. And just remind yourself, when you pull out a GCF, you're dividing. So if I divide the first term by 2 sine of x, I actually get 2 sine of x. And then on the second term, divided by 2 sine of x, I get a 1. I'm going to tee it up. And if I told you that 2 sine of x had to equal 0, we would divide the 2 over and still have a 0. I then want to visualize the sine curve. And it has a height of 0 at 3 different moments. Now, because our solutions, according to the last domain on the previous problem, our solutions had to be in degrees, we're going to say 0 degrees, 180 degrees, and 360 degrees. And there's, just be careful. If you said pi and 2 pi, but they wanted the answer in degrees, we would not receive full credit, unfortunately. The next one, we'll say 2 sine of x, add the 1 over, and now we'll divide by 2. That's a positive 1/2, so my solutions are in the first and the second. The reference angle is 30 degrees, which happens to be my first quadrant solution. And then I'm going to do 180 minus 30 degrees to get 150 as my fifth and final solution. So grand total, 3 solutions here combined with the 2 solutions over here, grand total of 5. On our third example, we're going to do the factor by trial and error. We have a trinomial, so unfortunately there's no GCF on this one. And I have a leading coefficient of 2, which makes things a little bit feistier. And because of that 2 right there, we came up with the name we're going to have to do trial and error. Now, of course, it's not called trial and have to get it right on the first time. It's called trial and error for a reason. Don't be afraid to make mistakes. As long as you're checking your work, you'll catch those mistakes and being able to correct them. So. Oh, the other good news was these first 2 terms were both in terms of cosine, so I didn't have to use any Pythagorean identities to substitute. I could just go ahead and start my trial and error. And I'm going to go 2 cosine of x on this side, 1 cosine of x here. Now I need multiples of 1, so well, that made life pretty easy, just 1 and 1. If you check your outer, let's see here, outer would be 2 cosine of x. The inner would be 1 cosine of x. And if I added those 2 terms, I would certainly get the 3 cosine of x. So we're feeling pretty good so far. We're going to tee this bear up. And we've got the cosine of x is equal to negative 1/2. And so I'm going to go ahead and finish that side of the t off right now. Now, because that's a negative 1/2, my solutions are going to be in the second and the third quadrant, according to cosine. My reference angle for the 1/2 is going to be 60 degrees. 180 minus 60 is going to give me a solution of 120, or 180 plus 60 for the third quadrant is going to give me a solution of 240. So there's 2 solutions so far. On the other side, I'm going to have to slide up the screen just a hair. Okay, we're going to subtract the 1 over. Now this is one of those situations where we want to just visualize the cosine curve. It has a height of negative 1 right there, which occurs at pi, and pi can be expressed as 180 degrees. If they want degrees. So 3 solutions this time, 2 on this side and then 1 more for a grand total of 3. Alright, for this quadratic formula one, I got my hard hat on, I've tightened my bootstraps, and I'm ready to go to work here. I think in my opinion this is the hardest one, and it's the longest one. It's going to take me about as much time as it did all the others combined. And after trying some trial and error, I didn't have any luck, so I decided to toss in the white flag and try some quadratic formula. Now, it's not x equals, it's the tangent of x equals. And we're going to go negative b plus or minus, big radical, b squared, minus 4 times a times c, all over 2 times a. Alright, let's see if we can clean up the inside there a little bit. Hopefully you got your calculator handy, and if you don't, run out to your car, run up to your room, wherever you got to go grab it. And I've got 25 plus 12, which is 37, all over 6. Okay, once you get that bear, whoops, that's a 37. All right. Okay, here's where we're going to branch things off. And I'm going to switch my pen size so I can fit all this in here. All right, on this side of the branch, I'm going to say that the tangent of x is equal to negative 5. You know what, I'm going to do the plus sign on this side. Doesn't matter, I could have done the minus sign. And over here, you know what, I'm going to switch colors when I go to this side just to clarify. Let's do the tangent of x is equal negative 5 minus radical 37 all over 6. Now, from here on out, I suggest that you pick one side and finish that side before you do the other side. So I'm going to go back, I'm going to go over here to the left and do my blue side. And I'm going to go ahead and import some pictures to show you exactly how my calculator screen looks. And if you don't have the TI-84, you don't have the updated version, you're going to use a little extra set of parentheses or just do it in smaller steps. So on my calculator screen, basically a couple of things happened here. The first thing I did is I typed in the fraction using my alpha F1. I then stored that small value in my alpha A, and then I did inverse tan of alpha A to get my angles. Now, what's my paper going to look like if I'm taking a test? And I'm going to show you exactly what my paper would look like. The first thing I would do is I would communicate with the person grading my exam exactly what decimal I got. And then I'm going to just communicate the fact that I stored it in alpha A. I'm then going to say that x is equal to the inverse of tangent inverse of alpha A. Now the other important thing I'm going to say to myself, well, because that value up here, the 0.18046 was positive, my solutions are going to be in the first quadrant and the third quadrant. So the reference angle that I got on my calculator is actually one of the solutions. I'm going to throw that in the, let's see, 10 degrees, rounding to the nearest degree is quadrant 1. And then I could do 180 plus the 10 degrees to say 190. 190 degrees is my second solution. So there's two of the solutions, and we're now going to graduate to the red side here. Again, I'm going to import some calculator screens to show you exactly what I had. Okay, the right side here had one extra trick along the way, but you'll notice up here at the top, now the light was kind of flashing on my screen here just right, so it's a little harder to see, but I typed in my fraction using alpha F1. Now, what happened was I got a negative value right here. I got a negative 1.8. So what I'm going to say here is I'm going to say on my paper that the tangent of x is equal to negative 1.847-ish, yada, 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 and I'm going to store that in alpha B. Now the trick is, now because there's a negative right there, I know right now my solutions are going to be in the second and the fourth quadrant, according to All Students Tip Cows. Once I identify my quadrants, that negative is now meaningless to me, and that's why you'll see on my calculator screen I multiplied by -1, and then after that I stored it in B. I did we could say that x is now equal to the inverse tangent of B, and my reference angle is going to be 62 degrees, rounding it correctly to the nearest degree. That's not a solution, that's just my reference angle. Now I need to do 180 minus 62. That's going to give me 118 degrees. That's actually a solution. And I'm going to do 360 minus 62 to get 298. And there's my fourth solution. So I've got a grand total of 4 solutions, 2 blue, 2 red, and that's a lot of work. Alright, hang in there. We just got 2 left, and I think they're easier than the one we just did. We got the hardest one out of the way. Now, the big problem we got here in this one is that my first term is in terms of sine, but my second term is in terms of cosine. That is a big red flag, and we've got to address that. We have to rewrite the equation so that it is in terms of just one trig function. And so we're going to go back to our good friend, the godfather, the Pythagorean identity. Now, if you'll recall, the godfather in its original form says that sine squared plus cosine squared is equal to 1. Now if we subtract the cosine squared over, we could say that sine squared is really equal to 1 minus cosine squared. What we're going to do is we're going to take this expression right here and we're going to substitute it in for sine squared. Alright, so now we've got 1 minus cosine squared in for that first term, and then I'm just going to copy down the rest of the equation as I see it. What I'm going to do here is I'm going to start to move all my terms to the right side. Whoops, I just caught a typo. I wanted the -1 to be a +1. So let's make that adjustment here before we go any further. I just caught that. That should be a +1. So what I'm going to do is I'm going to take my negative cosine squared. I'm going to add that over to the other side. So now that's positive cosine squared. I'm going to take the positive cosine here and subtract it over. And then if I combine the two ones on the left side, if I combine this term with that term, I'll get +2. Subtract it over is -2. So I'm just moving everything over to the other side of the equation. Now I have to ask myself, hopefully it's factorable, and that was my intention. That's why we caught that little mistake earlier. So we've got the cosine of x times the cosine of x. I'm going to say -2 plus 1. Those two numbers add up to the middle coefficient and they multiply to the third term. So I think we're good to go. We're going to tee this up. We're going to ask ourselves, when does cosine have a height of 2? And the answer is never. So I'm going to put a non-existent symbol there. And then I'm going to say, when does the cosine curve have a height of -1? Visualize the curve, and it's got a height of -1 right at 180 degrees. So we did all that work just to get one solution. How ironic is that? But that is the final answer, only 180 degrees. Well, I tell you what, we are definitely getting better at spotting our double angles, and we caught one right off the bat right here. So we're going to go to our reference sheet. Now, Cosine of 2x is a little bit more challenging than the sine of 2x. When you look at cosine, you've got three options, and you've got to be careful to pick the most efficient one that's going to make your life the easiest. Now, when you see sine in the second term, that means you should probably pick the formula that is in terms of sine. And so I grabbed the one that said 1 minus 2 sine squared off of my reference sheet. And then I'm just going to copy down the rest of the equation as we see it. So there comes that term, and then there comes this term straight down. Now I'm going to kind of combine my like terms and move them all over to the right side. So I'm going to add 2 sine squared over so that it's now positive. I really prefer that term to be positive. I'm then going to add 5 sine x to the other side. When I combine the 1 and the negative 3 on the left side, that gave me negative 2. Now I want to add it over. So I've got this. And now I'm just going to keep my fingers crossed, kind of hold my breath, hope it factors. I'm going to do 2 sine of x times 1 sine of x. And then the multiples of 2, I got to play with them. It could be plus 2 plus 1 or vice versa. I ended up putting the plus 2 here so that my outer was 4 sine of x. And then I had a plus 1 here, so my inner was 1 sine of x. Add the outer and the inner together, and it does give me the 5. So the good news is it factored beautifully. We're now ready to tee it up. We could say, well, when does the sine of x equal negative 1/2? Ooh, we got our work cut out. Because it's a negative right there, our solutions are in the third and the fourth quadrant. We've got a reference angle of 30 degrees. That's straight off our flashcard. Let's see, 180 plus 30. We're getting better at this, aren't we? 210. 360 minus the reference angle gives me 330. There's 2 solutions. And then over here we ask, when does the sine curve have a height of negative 2? And I'll tell you what, never. So we got 2 solutions. Now, on this very last one, I want to play devil's advocate and ask you, what if they wanted your answer in radians instead of degrees? All you would do is you'd remind yourself that 30 degrees is pi over 6. We've got that memorized. That's on a flashcard as well. Now I'd say to myself, 3 goes into 21 7 times. So I'm going to have a multiple of 7. 7 pi over 6. And then 3 here goes into 33 11 times. So 11 pi over 6. Those would be my 2 solutions in radian form. Hope you feel a lot better with these trig equations. We've covered a lot of different elements tonight. And I hope you've developed some confidence and you're ready to dominate in tomorrow's session.